Hey guys, and I welcome you all to my Dr. GY lectures. Today I am going to speak about the topic about the elastic deflection of beams. This topic is totally from strength of materials subject. So since we come across so many topics in our previous lectures, we just covered about the stress, strain and deformation of the solids, and along with that, that is a beam bending and as well as the shear force and bending moment diagram, which we have seen in our previous lectures. And in continuation with the previous sessions, I'm just going to carried out the another unit, that is what do you call the deflection of beams. Okay, so in this deflection of beams we just go on study because of the load how the beams has been deflected from its initial position, and what are the methods that we need to analyze with the help of those methods. How can we analyze the deflection, and what are the types are there. So in this way we just covered in all aspect about the deflection of beams. Okay, so here the contents of today's session is about the introduction, second one double integration method, third one the example for the above methods, and fourth one it is about moment area method, and fifth one it is an examples. Okay, so let me see that. So generally what do you mean by deflection? For example, you just seen these two different diagrams are here. So in these two different diagrams, here we having a simply supported beam, another one is a fixed beam, and there is a eccentric load which has been act over the beam. So because of the load, what happened whenever the load has been applied, because of the load the beam has getting deflected to some distance. So here this y represents, this is what do you call that displacement, is also called it as a deflection. Deflection means the amount of beam bending from the initial position. Okay, so it can be represented by the symbol is called y. Okay, so this is what you call that deflection. So it may be necessary to determine the deflection for every value of x. Here this x represents wherever the deflection taken place. Okay, we just need to take a calculation from the simply supported end, because from the fixed end we don't have any kind of deflection is there, but whenever there is a simply supported beam has been acted, because of the load it can make some deflection from the simply supported end. Okay, so that is why it may be necessary to determine the deflection of y for every value of x along with this beam. This relation may be written in the form of equation, which is frequently called it as an equation of deflection curve, or also called it as an elastic curve of the beam. Okay, so the importance of beam deflection, every designer for analyzing the beams, it is we need to following some codes. Here they are using for building construction beams. For example, they are using for the bridge construction. So as I said, there is many different kind of methods that we are using to analyze their deflection. The most important method is called double integration method. Okay, and following that moment area method. So the name itself gives the details. Double integration means we just need to integrate the following. Integrate means we just need to take a two different extreme ends, one at extremely zero deflection, another one is a maximum deflection. So whenever there is a two different ranges are there, we need to prefer for the integration. So hence we need to prefer for double integration methods. Okay, and second one, there is a moment area method. We need to analyze with the help of moment with respect to the area, how much amount of moment taken place with respect to the given area of the beam. Okay, accordingly we need to calculate their deflections by using some basic deflection equations. With the help of these two methods we are analyzing their deflection levels, and we're just going to point out where exactly the deflection will make in the given beam, whether it is a simply supported beam or whether it is a cantilever beam. Accordingly, we need to calculate by using these two different methods in our upcoming studies. Thank you so much.